Today we're going to talk about some specific types of integrals that end up involving natural log and trig, because in order to take them, you end up with a natural log in your answer. So again, we're not taking an integral of a natural log function, but we're getting a natural log when we take the integral. We already know a basic integral for sine of u du. We know that's negative cosine of u plus c, right? We know the basic integral for cosine of u du is sine of u plus c. Now, what we don't know yet, and that we're going to find out today, are the integral rules for a basic tangent of u, secant of u, cosecant of u, cotangent of u. We know some other variations of those based on some derivatives that we have, but we don't know the actual integral formulas. So the integral of tangent of u du is negative natural log of absolute value of cosine of u plus c. I want you to think for a minute why that is. Think about what tangent is. Tangent is sine over cosine, right? Think about if you were taking the integral of that. If you were taking the integral of that function, cosine could be your u, du would be negative sine of x dx, so you would have the negative of the du. When you take the integral of 1 over u, you get natural log of absolute value of u. That's where this function comes from. Okay, just so you know, you don't have to know that, but if you were curious, that's where that comes from. Integral of secant of u du is natural log of absolute value of secant of u, doesn't look like a plus, secant of u plus tangent of u plus c. Okay, integral of cosecant of u is negative natural log of absolute value of cosecant of u plus cotangent of u plus c. And integral of cotangent of u du is positive natural log of absolute value of sine of u plus c. So you definitely want to make sure that you have these rules written down to reference, because you are going to use these. We're going to start using these in some examples. Let's start with a pretty basic one. We're going to start, and we're going to actually go ahead and jump in and do a definite one, but let's start. Let's say we have the integral from 0 to pi over 4 of secant of x dx. Okay, we just said that the integral of a plane secant is natural log of absolute value of secant of x plus tangent of x. This one's nice. We don't have a u, so it's a lot easier. And let's put in our limits of integration. So let's plug in natural log of absolute value of secant of pi over 4 plus tangent of pi over 4 minus natural log of secant of 0 plus tangent of 0. All right, so let's see what we got. Secant of pi over 4, square root of 2. Tangent of pi over 4 is 1. So this is positive. We can actually change these to parentheses because it's already positive. Minus natural log of secant of 0 is 1, plus tangent of 0 is 0. Notice here we've got 1. Natural log of 1 is 0, so this piece is gone, and all we have left is natural log of square root of 2 plus 1. We would leave our answer like that. We don't have to simplify down unless it was calculator active, which this is too easy to be one that would be calculator active. This would definitely be considered calculator inactive. All right, let's try one with some u substitution. Let's say that we have the integral of tangent of 4x dx. Okay, first of all, what makes this different from a regular tangent is that we have the 4x, right? So we know our u is going to be 4x, so our du would be 4 dx, the derivative of that. If we rewrote this in terms of u, we have tangent of u, and then we have 1 dx. We only have a dx, so we have 1/4 of the du. I'm going to put the 1/4 out front, okay, because it's just a constant. So 1/4 is a constant out front. Now, the integral of tangent of u is negative natural log, so I'm going to put a negative on top of the 1/4. So negative 1/4 natural log of absolute value of cosine of u plus c. Let's plug back in the u, negative 1/4 natural log absolute value of cosine of 4x plus c. And that would be our integral. That would be done. Okay, let's try one more. Let's say we have the integral of cosecant of 2x. Oops, not cosecant of 2x, dx. Okay. The 2x is what makes this different from just a plain cosecant of x. So our u is going to be 2x. So our du would be 2 dx. Let's rewrite in terms of u. Cosecant of 2x is cosecant of u. We have just a plain dx, so we will have 1/2 of the du. I'm going to put the 1/2 out front. 1/2 is just a constant. Now, we said that the integral of cosecant of u is negative natural log, so I'm going to put a negative out front. Natural log of absolute value of cosecant, oh boy, cosecant of u plus cotangent of u plus c. So let's plug back in our u. That's negative 1/2 natural log of cosecant of 2x plus cotangent of 2x plus c. And again, we would just leave it like that. This would be one, again, that would be calculator inactive. Even if you're plugging something in, they expect you to know your trig values. So make sure if that's something that you struggle with, that you kind of go back and do a little bit of review of your trig values, because a lot of times they'll give these problems on the calculator inactive section of the exam because they are testing both of those at the same time. Not only do you know these integral rules, but do you also know your trig values?